Imagine walking into a bustling farmer's market. The sights, sounds, and smells are overwhelming, but you're on a mission. You're looking for the ripest, juiciest apples for your world-famous apple pie. But how do you find the best ones? You'll likely look at the color, feel the firmness, and maybe even smell the apple. All these characteristics or features help you determine the best apples for your pie. This process, in essence, mirrors statistical feature extraction in machine learning. Dive into the world of machine learning, and you'll find that statistical feature extraction plays a pivotal role. Like selecting apples, machine learning models also need to identify the most relevant information from a sea of data. Think of a machine learning model as a detective, and the data it works with as a crime scene. The detective doesn't need to know every single detail of the scene, just the critical pieces of evidence that can lead to solving the case. These crucial pieces of information are the features, and the process of identifying them is feature extraction. Statistical feature extraction specifically uses mathematical measures like mean, median, mode, and standard deviation to extract and identify these features. For example, consider a dataset of house prices. The average price, the highest and lowest prices, and the price range variability could all be critical features for predicting future house prices. Now, delve into a more specific application of statistical feature extraction: machine fault diagnosis. Machines like cars or industrial equipment generate a vast array of data from their various sensors. However, not all this data is useful for diagnosing a fault. For instance, when diagnosing a car engine's fault, the relevant features might be the average temperature, the maximum RPM, or the variability in oil pressure. These features are extracted from the raw data using statistical methods, helping to pinpoint the cause of the fault accurately and efficiently. In summary, statistical feature extraction is a critical process in machine learning. It involves identifying the most relevant information or features from a large data set, much like finding the best apples at a farmer's market. It uses mathematical measures to identify these features, and it's used in various applications, including machine fault diagnosis. Remember, just like the perfect apple pie depends on choosing the right apples, the success of a machine learning model depends on selecting the right features. So the next time you're at a farmer's market, think about statistical feature extraction, and perhaps you'll see your apple selection process in a whole new light.